We're given the vector u in component form and asked to find the magnitude and direction, where the direction is the angle in which the vector points measured counterclockwise from the positive x-axis, and we're told to give the angle theta in the interval from 0 to 2 pi radians. Let's begin by sketching the vector u in standard position, which means the initial point is at the origin, and then from here, because the x component is 6, we move right 6 units. And then because the y component is 4, we move up 4 units to determine the terminal point of the vector u in standard position. And therefore, in standard position, this is the vector u. Notice by sketching the x and y components, we now have a right triangle on the coordinate plane, which we can use to determine the magnitude of the vector, which is the length of the vector. We indicate magnitude using either single vertical bars or double vertical bars. I'm going to go ahead and use double vertical bars. So the length of this vector here is the magnitude. Notice this is the hypotenuse of the right triangle, and then the angle theta is the angle formed from the positive x-axis rotating counterclockwise to the vector, which is this angle here in the first quadrant. So again, notice how because the magnitude is the hypotenuse of the right triangle, we can use the Pythagorean theorem and state that the magnitude of the vector is equal to the square root of the quantity x squared plus y squared. And then using right triangle trigonometry, tangent theta is equal to the ratio of the opposite side to the adjacent side, or we can say tangent theta is equal to y divided by x. Solving for theta, we have theta equals arctangent of y divided by x. When determining theta, though, we need to be careful because remember the output or the range of arctangent is the open interval from negative pi over 2 to positive pi over 2. So we do need to be careful to make sure we give the angle theta in the interval from 0 to 2 pi based upon the quadrant of the vector. Let's begin by determining the magnitude of the vector. The magnitude of vector u is equal to the square root of x squared plus y squared, which is equal to the square root of the quantity 6 squared plus 4 squared, which is equal to the square root of 36 plus 16. The sum is 52. The magnitude of vector u is equal to the square root of 52, but we need to simplify this if possible. It will simplify if 52 has any perfect square factors. To see if it has any perfect square factors, let's determine the prime factorization. 52 is equal to 2 times 26, 2 is prime. 26 is equal to 2 times 13, 2 and 13 are prime. Notice 2 times 2 or 4 is a perfect square and is a factor of 52, and therefore this will simplify. We can write the square root of 52 as the square root of 4 times the square root of 13, which gives us the simplified exact magnitude as 2 square root 13. And now let's determine the direction of the vector, which is the angle theta. Theta is equal to arctangent of the ratio of the opposite side to the adjacent side, or y divided by x, which is 4 divided by 6. Simplifying, we have arctangent 2/3. Notice our angle is in the first quadrant, and this angle is in the range or output of arctangent, and therefore the calculator is going to give us the angle that we are looking for in one step. This will not always be the case. And notice how we are told to round to 3 decimal places. So going to the calculator, we first need to verify that we are in radian mode, not degree mode. So we press the mode key, and notice how radian is highlighted. If it wasn't, we would highlight radian and press enter. Going back to the home screen by pressing second mode, we press second tangent, 2 divided by 3, close parenthesis, and enter. To 3 decimal places, we have 0.588 radians. And notice how this angle is in the interval from 0 to approximately 1.57 radians, verifying once again this is the angle we are looking for, which is called the direction of vector u. I hope you found this helpful.